What did we get?
5,024.
5,024. I hate to break it to you now.
What? Did all we added all the numbers? What if we're just with
You skipped a number.
Did you forget 100? No, I added 100.
Okay, what other people? What'd you get? Hmm?
Oh, Mary's got it. It wasn't right. Was it you? No. Maybe.
Anyone else get an answer? You legitimately have a calculator. Could you not add the numbers between 1 and 100?
That's what I did.
You guys worked together and it didn't work out.
Oh, wow.
That's actually one of the challenges with working together sometimes is it's really easy. So you're relying on multiple people to not make a mistake. Okay. Anyway. If there was not a plus sign between all these numbers, if it was a comma, if it was a sequence, 1, 2, 3, 4, all the way up to 100 would be what kind of a sequence? Plus 1, which would make it arithmetic. So this would be an arithmetic sequence, but it's not a sequence.
5,050.
Yes, it is 5,050. This is an extremely famous arithmetic series. It's extremely famous because of how it's connected to the mathematician Frederick Gauss. When Frederick Gauss was in elementary school, his teacher wanted just a little bit of time to kind of work on some things. So the teacher put this question on the board. Remember, this is pre-calculators. And just kind of said, do the problem. Gave it to a bunch of elementary kids with the idea of getting a little bit of time to work on things as the elementary kids just kind of slowly added these numbers together. And it took just a couple minutes for one of these little elementary kids to step up and say the answer is 5,050. And it's because rather than just simply adding up the numbers, Gauss, which now I'm second guessing the first name of, I said Frederick, but now my brain is saying Carl, and I don't know why. I think it's Frederick. It might be just a different mathematician. Don't mind me. Gauss. The last name I know is correct. He found a different way to do it. He said rather than going through and adding every single one of these up, I'm going to instead notice a pattern. The pattern he noticed, he started by taking the first and the last number and saying, okay, what is 1 plus 100? 101. What is 2 plus 99? 101. What is 3 plus 98? 101. What's 4 plus 97? 101. Could I keep going?
Yes.
So, instead of just adding them, he systematically added them. He said the first and the last is 101, and then if I move in 1, it's 101, and if I move in 1, it's 101, and if I keep moving in 1, it'll be 101 every time. But how many 101s are there?
50.
50. How'd you get 50?
Because there's 2 numbers in each pair, and then it's half.
Because there's 2 numbers in each pair, and there is 100 numbers in this list. And 50 times 101 is 5,050. So, this is how he came up with the sum of the first 100 natural numbers. Now, let's break this down a little bit. Let's get a formula out of this that we can recreate, because that's what we're getting into today. We're getting into adding up arithmetic sequences And when you add up a sequence, you have what's known as a series. So, let's start with the 50. Where did the 50 come from again? Half of, now it's not technically half of the 100. Yes, 50 is half of 100, but it's not just half of this last number in the list. How did you know to take half of 100? It's the amount of numbers. The amount of numbers in the list. Now, the amount of numbers in the list comes back to the fact that if I think of this as a sequence, this right here is called A sub 1, and this right here is called A sub 100, because there are 100 numbers in the list. That's our A sub n. So in this case, n was 100. So n got divided by 2. And then we multiplied that by the 101. Where did the 101 come from? Initially, it was the first digit and the last digit put together. What do you call the first digit in a sequence? The first term. A sub 1 plus. This one was A sub 100, but it was only A sub 100 because we knew it was the 100th term. So generally, that one is A sub n. This is how you find the sum of an arithmetic sequence. Now, it's only how you find the sum of an arithmetic sequence in the situations where you know what n is, what A sub 1 is, and what A sub n is. If you do not know those three pieces of information, you cannot find the sum. Sometimes they will phrase what they want you to do differently. For example, this one, I could have given you this setup, or I could have asked, what is the sum of the first 100 natural numbers? That is the equivalent question. It's just phrased differently. Natural numbers are your counting numbers. Your 1, 2, 3, 4, 5, and the first 100 of them is 1 through 100. So it's the same exact question. But in this situation, I am missing a key piece of information. Now, granted, we could easily figure out that the 100th natural number is 100, but it's not uncommon that you don't know what the last number you're adding is. It's not uncommon that this is missing. And in that case, if I want to find the sum, I have to approach the problem differently. I still have that n over 2 getting multiplied by A sub 1 plus. But what if we're missing this term? If only we had a formula to find A sub n. Do we? What's the formula for A sub n? A sub n equals A sub 1 plus n minus 1 in parentheses times d. Now, we are adding these. When you're adding, do you need a parentheses? Like, I'm not talking these ones. I'm talking like, do I need to put a parenthesis around this when I substitute it in? No. I'm going to replace A sub n with this. A sub 1 plus n minus 1 times d. And I'm going to simplify what I can, which is really just combining like terms. What is an A sub 1 plus an additional A sub 1? Not squared. That would be A sub 1 times A sub 1. 2 A sub 1s. this is another way to find the sum of an arithmetic sequence. So, the point of today's warm-up was really to derive our formulas that we're using today. Do you think I'm going to make you derive the formulas again? No. I show you how to derive the formulas because if you know how to get one, that can help you find the other in the future. It's about being able to build stuff out when you get to that point in math, if you choose to continue math that long. But it's an option. We are still in section 10.2. But today we're getting into series. A series is simply the sum of a sequence. So rather than just having the list, now we are going to start adding up the list. One of the things you're going to have to do in this class is you're going to have to be able to differentiate between not only when something is arithmetic and geometric, but when it is a sequence or a series that I am asking you about. Sometimes it's very obvious. Other times you're going to have to put a little bit of thinking into it. So, our arithmetic series partial sum formulas. Partial sum indicating we're only adding up part of the sequence. Because how long are sequences? Infinitely long. Can we add up an infinite number of numbers? Not yet. Series generally start S sub n, indicating that you're finding a sum. And the formulas were what we had on the first page. N over 2, a sub 1 plus a sub n, or the alternative, n over 2, 2a sub 1s, plus n minus 1 getting multiplied by d. S sub n represents the sum of n terms. N still stands for a position within this time of series. Specifically, it's the position of the last term. Tells us the location of the last term that we're adding. Now, as it tells us the location of the last term that we're adding, it also essentially represents the number of terms we're adding. A sub 1 still stands for the first term. A sub n still technically stands for the nth term. But when we're adding up n terms, the nth term is the last term. And d is still our constant or common difference. So we're going to find the sum of the following series. Kind of looks like the setup of our warm-up. But there is one big downside of this as compared to our warm-up. And we'll find what it is here in a minute. If I want to find the sum of the series, I'm going to start by just identifying what information I know. What of these that I know? S sub n stands for the sum. Do I know that? No, that's what we're looking for in the end. It's what we want. Do I know n? Do I know either the number of terms I'm adding up or the position of this term? No. And is on our need to find list. Do I know what a sub 1 is? 7. Now, I don't need both a sub n and d. If I know I'm both, great. But I need at least one of them. Do we know what a sub n is? 51. Do we know what d is? 2. Remember, d is the difference between the terms. From term to term, I had to add 2. Now, in all technicality, there's actually one thing I do before this. I determine if it's arithmetic or geometric. Arithmetic, how do we know it's arithmetic? From term to term, it's adding. I also check if it's a sequence or a series. How did I know that this one was a series? Because I'm adding. I got plus signs in between. If it was commas, that'd be a different story, except my instructions still say find the sum, so it would still be a series. But the most challenging part of chapter 10 is not the individual formulas, it's knowing when to use which one. So checking that first is going to be an important piece. Now, going back to the problem at hand, I want to use my sum formulas. Both of them need n. So I have to find this. If I am missing n, my S sub n formula is not going to help me yet, because I have two unknowns in the S sub n formula. I don't know what S sub n is, and I don't know what n is. Doesn't matter which of the two formulas I pick, I still have two unknowns. So, here's where I use something else to my advantage. A series is nothing more than a sequence added together, which means it fits all the characteristics of a sequence except having plus signs. That means my arithmetic sequence formula can help me find missing things, such as n, as long as I know the other pieces of it. We established earlier, we know what an a sub n is. It's 51. Equals. We know a sub 1 is 7. Plus. We don't know what n is. That's the problem. But we know d is 2. If I know all those things, I can plug them into that formula, and then can I solve for n? Yes, what should I start by doing?
Simplifying 2 and then -1.
Yes, simplify that by distributing. I'd probably simplify again by combining like terms. A 7 on -2 is 5. subtract my 5, I get 46 equals 2n. And divide by 2, and n is 23. Now that's not what I wanted in the grand scheme of things, but it gets me closer. What I wanted in the grand scheme of things was to find the sum. In other words, I wanted S sub n. Now for S sub n, I have two formulas. Which would you rather use in this case? A sub 1 plus A sub n? Do we have the information necessary to use this one? Yeah, if you have the information to use the easier one, use the easier one. If you don't have the information to use this one, that's when we use this one. So n is 23 divided by 2. A sub 1 is 51 plus A sub, let me try that again. A sub 1 is 7. A sub n is 51. Don't mind me. I can either type that entire thing into my calculator, or I personally say what is 7 plus 51 first. And then I type that into my calculator. S sub n would be 667. More accurately, it is S sub 23, because much like A sub n and S sub n, that subscript is technically there. Am I upset if you tell me it's S sub n? No. First 20 terms of 7, 4, 1, negative 2. First off, keep an eye on your instructions. What did the instructions tell us to do? That's not the instructions. Find the sum of the series. Arithmetic or geometric? How do you go from term to term here? -3. Is that an arithmetic or a geometric feature? Arithmetic. Is this a sequence or is this a series? It is not a sequence. It looks like a sequence. I will agree with that. Here's how it's not a sequence. What are the instructions? Find the sum. If I'm asking you to find the sum, is it still a sequence? No, it is a series, because the sum of a sequence is a series. So I can list something out like a sequence, and the moment I tell you to find the sum, you're no longer working with a sequence. You are now working with a series. To work with my series, the variables I can work with are S sub n, A sub 1, A sub n, and D. Do we know what S sub n is? No, that's the sum. That's what we're actually looking for. Do we know what n is? 20. We know what n is this time. We're adding up 20 terms. A sub 1 happens to be 7 again. Do we know a sub n? No. Do we know d? D is -3. I'm missing a sub n. Now I could use the arithmetic sequence formula to find a sub n if I need it. But the question is, do I need it? No, I have a formula that doesn't require using a sub n. N on the previous problem I had to find because I don't have a formula that doesn't use n. But I do have a formula that doesn't use a sub n. I don't need it. Could I find it? Sure. Do I need to? No. I simply have to use this formula instead. S sub n equals n is 20 over 2, parentheses 2 times a sub 1 is 7, plus 20 minus 1 times d. I could put that entire thing into my calculator as is. The calculator will do all of that math. You want to do it in pieces, do it in pieces. That's fine. If you're going to do it in pieces, 20 minus 1 is 19. 19 times -3 would be -57. 2 times 7 would be 14, and I would add the 14 and the -57? And then multiply it by the 20 divided by 2, which is just 10. But my calculator knows how to do it just as well. S sub n is -430. Again, technically it's S sub 20. I don't care which form you give it to me in. I have another example, but I don't think it's going to make anything like more or less clear, so we're just going to switch over to work time. If you are stuck on things, please ask. I am happy to help. What's happening tomorrow? We do have a quiz.